Hi guys, in this video we're going to be talking about electric circuits, which you've started to investigate in class, and how electric circuits work and some of the really important things that you need to know about circuits. So, as we discovered in our experiment, if a circuit is going to work, we need two things. We need some sort of power supply with a positive and a negative terminal. Now in class we used a power pack that had a positive and a negative terminal, but that could also be a battery as well. Remember batteries have got a positive and a negative as well. The other thing we need is a continuous path of conductivity from one of those terminals to another. So what that means is we need to have from the negative to the positive, we need to have some sort of material that conducts. Now in a normal circuit that might be a wire, but there's other sorts of things that can conduct electricity as well, and that basically gives a way for the electrons to move through the circuit. So in this little diagram here we've got our power source, and then these lines represent the conductive wire that the electrons can move through. And then we've got what we call a load, so something that the electrons are working on, which is a light bulb in this case. And we've also got a switch. Now all a switch does is it enables us a way to basically break the circuit. If the switch is open, there isn't a continuous path of conductivity, so the electric circuit doesn't work. But if we close the switch, then there is a continuous path, and so the circuit will light up. So basically in a electric circuit like this, like I was saying, electrons move from the negative terminal, which in this case is that one, towards the positive terminal. And that's because electrons are negatively charged, and negative is attracted to positive. Just like magnets, how north and south are attracted, negative and positive are attracted. So the electrons, which are negative, come out of the negative terminal, and they want to move through that circuit. We'll pretend that the switch is closed. They want to move through the circuit towards the positive terminal. Now, if our circuit has something in it like a light bulb, as they move through the light bulb, basically a light bulb's made out of a material that will emit light when the electrons go through. So really, when we build a circuit, often what we're doing is we're tricking those electrons into doing something useful for us. That's the whole reason for having a circuit. So we just come to this measurement that we call current, and you would have heard me talk about this before, but current is basically a measure of how many electrons are flowing through a particular point in a circuit. So if we pick a point in the circuit, for example, let's say we're talking about here, current would be at any given moment how many electrons are flowing past that point. It's like if you were standing on the side of a river and watching how fast the river was going past you at that point. So current is measured in something called amperes, but we normally just shorten it to amps because that's a bit easier to say. And we write that with a capital A. Now you might also see it written as milliamps, which is a little m and then a big A. So milliamps are just 1,000th of an amp, just like millimeters are 1,000th of a meter. Okay, so this is just how we measure current, is in those units. Now, current is going to depend on two different things. First of all is the voltage being provided to the circuit. So voltage is basically the difference in electrical energy between 2 points in a circuit, and it basically provides the motivation for the electrons to move. So if you've got a really high voltage, the electrons are going to be really motivated to want to move from the negative to the positive. If you've only got a small voltage, they're not that motivated. Okay, so we know, there are some circuits and things out there that could be up in the thousands of volts. The power point in a wall is 240 volts. A small battery is only 1.5 volts. So voltage can differ quite a bit depending on what you're doing. The other thing that's going to determine your current is the resistance in the circuit. So the resistance is how hard it is for electrons to move through. So if there's a lot of resistance, for example, if you had an electric motor in a circuit, it's going to be hard. The electrons have to do a lot of work to get through the circuit to make that motor turn. And so the current is going to be low. But if you have a really low resistance, like maybe you've just got a little light bulb, then the current can be quite high. Okay, so voltage increases the current, resistance decreases the current. Okay, what I want you to do after watching this video is go to page 147 of your textbook and answer the questions there. That will just help you to solidify what you've learnt. If you can't remember some things that I've said in the video, you can always have a flick back through the pages before that in the book as well. Okay, thank you for watching and good luck.